Hi everyone, welcome to video 5 of the Raspberry Pi Rack series. So today we're going to cover 4U panels, and I'll be releasing those files today as well. In addition to that, I have some pre-recorded screen captures that I'm going to throw into this video about how to do derives from the 5U panel that I'm going to release in the next video. But essentially, all of these 2, 3, 4, and 5U components derive directly from the 5U panel. And so you'll easily pick up on that and be able to make whatever sizes you need, however big your printer is. I capped mine at 5 simply because build volume on the Mark III is limited in space. Not to mention I only needed 5 anyway for the different sections of my rack, so it kind of worked out perfectly for me. But anyway, let's go ahead and drop into Fusion 360, and I'll show you what we're working with today. So the first panel, this is the back 4U panel. So you have your magnet here, your hinge here and here, and it's pretty much identical to the 2 and 3U sections. So nothing's really changed there. As far as the 4U panels for the left side, pretty much the same as the 2 and 3U sections. You got your magnets here, your hinge pins here. Again, it's only about another, 40 millimeters per U. So we just kind of added a section in here, right? Well, actually, what we did was we derived and we cut a section out from this, or from the 5U panel to make a 4U panel, but we'll get into that in a few minutes. Anyway, so this is the left side, right? Again, it's pretty much identical to the 2 and 3U sections. Same for the right side. The right side, you've got your magnets in all the places, and everything is pretty much identical. The only thing I will say is that with these, I did not print these with the same filament that I printed the rest of the rack with, because I'm not going to use them. So I used some cheap filament. Everything seemed like it turned out exactly the way that it should, but there's no reason to waste, expensive good Prusament on parts that I'm not going to use. So if you find issues, be sure to let me know, and I'll go through and fix them and release new parts again. I'll also be releasing, much as the 2 and 3U sections, I'll be releasing a version of these without the holes. So you should be able to print that without bolts if you want to as well. So let's go ahead and drop into the slicer. We'll get the slicer settings for each of these, and then I'll pop you into the Derive video. All right, over in PrusaSlicer, we've got the default settings set, so let's go ahead and import some things. All right, we'll start with the back 4U panel. Pull that in. Again, these things just print on the back as usual. So just like that, we'll center it. We're going to set our print settings to 5 and 5. So that looks good. Infill of 15, no supports. That's really all that's needed for this part. Let's go ahead and slice that. All right, 4 hours, 25 minutes, and $1.99 in filament. Yeah, so looks good. Let's go ahead and get started on the next one. Just import it that way. Okay. Left panel. All right, again, with these, they do need supports because of the holes in the hinge pins. So let's paint some of those on real quick. All right, come on. There we go. I think I've got my DPI settings finally set, so we should be good on putting these on now. Certainly better. Okay, cool. All right, and that, and that. Now we're gonna lay it on its face. Center it. Supports. Support enforcers only. Turn on bridging perimeters. Again, 5 and 5. 0.2 quality on Prusament. Slice. And we're at 8 hours and 43 minutes. And as you can see, it looks like we've got all of the supports that we need. That's a $3.56 part though, so we're starting to get into the expensive parts now. All right, so on to the next one. All right, right panel. Right, just like the left panel, this one needs supports as well. So right in here. Now, I've had luck just popping these things out with a screwdriver, right? So just a tiny little, like a watch size screwdriver, just nothing big. And you just pop it in there and they generally just pop right out. Yeah, once you do that though, there may be a little bit of remnant in there. So I use a small flat screwdriver to just kind of go in and clean up all those edges in there. It turns out pretty well. We need to lay it on its face, don't we? Let's try that. And I bet that works better. Okay, again, support enforcers. Okay, so 8 hours 43 minutes, $3 55 cents in plastic. And that looks like it needs to be exactly what we're looking for. Okay. All right, so now that we've got that out, I'm gonna go ahead and kick off the screen recording that I made for Derives. I think you're gonna enjoy that. There's some really cool content there. So, all right, happy printing. All right, so today we're going to talk about derives and right side panels. The side panels for both the left and the right side are derived from a single component. I'm going to pull that up and show you what I mean. So if you look at this, both sides are exactly identical, being this and this. So if I change a feature here, I'd want to change it here. And the key here is that I can change this kind of dovetail mechanism for the interlocking components in one place, and it will trickle down to the rest of them. Now, the the major change that we need to make today is that I don't have a for you right side panel created. And to do that, I'm going to show you my workflow and we'll get going with it. So set this for. Now, I have to save this component in order to actually derive. Now we're going to set this for our base Pi rack. Let's go ahead and set that. Now, inside here, we're going to import our derive. And the derive that we're going to use is the right 5U panel. So I don't have a 4U. I have a 2 and a 3. I'll show you a little bit about the 2 because that's kind of important. I had to make some changes to that one in order to get the magnets to work. So if you look, now we have our imported derive. Our magnets come in here and here. If we're going to slice this thing up, we have to remove this feature because obviously that wouldn't work. It's dead center in the middle of the design. By cutting it up, it just wouldn't place properly. So we're going to re-add that after we slice this thing up. So now that we've got that removed, we're going to go ahead and create a new sketch. And on this sketch, we're going to slice up the components as we need. Now, I know from here to here, that's going to be 120. And of course, we'll just lock to the back section over here. Now, let's add another one. This will be what we actually use as our slicing tool. Let's go all the way to the back again. We'll set that to 40. And so what we're going to do is cut out this 40 millimeter section. That's 1 U height. Let's go ahead and do that. We're going to split this body. We're going to split this tool off of this. Okay, so now we have 3 bodies. We're going to create a new component. We'll just name it the same thing as the actual design. We'll pull in the body from this. So you can see I have 2 bodies here that I need to grab. We're going to move that to there. And now at this point, we can go ahead and turn that off. Now what's cool is, even though this is not the actual component we're going to use, these came from that. And so if I make a change in the referenced object, the referenced derive side panel, it'll still change all of these. So it turns out pretty cool. Now, the 5U panel actually has some derived components in it as well. These magnets weren't here in the base side panel object, so those were added in the 5U side panel. In the 2U side panel, I had to make some changes to those to make them work, because obviously that would be too high. And then, of course, by adding a fillet and a chamfer in this section, it actually would get into the magnet portion. So I'll walk you through that here in a second. It's not that big of a deal. So let's go ahead and combine these two. First, I need to move that down by 40. Okay. Now we're going to take these two and we're going to combine them into one part. All right, so now we have a single component and we need to add magnets. So what we're going to do is go ahead and create a new section analysis right here. We're going to go back just a little bit to where we can see that. And then we'll start adding in our magnets. So let's add one. We'll go ahead and rotate it. Okay, 90 and 90. Pull it out so we can actually see that. And then let's go ahead and make a joint. Okay, we've got that one good. Let's go ahead and add one more. All right, create one more joint off of this. All right, and it looks like our 4U component is finished. Now, if you wanted to create like a 6U component or something like that, you could take the 5U component, slice it, copy a body, and then add in however many you want. They're only 40 millimeters tall, so you can add as many as you want. That said, I would say 5 is probably the max I'd want to go without having a section in the middle of that. But, you know, I could see the use case where some people would want to do some things differently. Let's go ahead and turn off our analysis, and this part is actually complete. So we'll go ahead and save that, but I do want to show you something else. So on the 2U panel, you can see here that instead of having the magnets come in the top, I wouldn't have had room to do that with this, so I put them in through the side. Now, that may or may not work for you, depending on the variance and the size of your magnets. My magnets kind of fit in there pretty good, but you may have to glue yours. What I liked about the other design of the side panels, they come in through the top. Gravity just kind of keeps them there, and they don't have the ability to kind of slide out and you know, go wherever they want to go. With this, if you open that back panel, they may flop out, so you may have to super glue those in. And additionally, the other reason I had to do that is because with this thing, it actually would get into those magnet sections because this is 3 millimeters. That's one other thing I need to add to this real quick. Let's go ahead and add that feature back. So we'll create a new sketch off of this, and what we're going to do is a 40 millimeter by 3 millimeter section, 40 by 3, and let's see, this is going to be there. So what, roughly about 60. So that gets us in the middle for that sketch. And now what we're going to do is actually extrude that by 3 millimeters in. Wrong direction. Let's try that again. All right, now as you can see, we have a little bit of a problem here. So this is actually going to be problematic for our design. And so what I'm going to do is I'm going to back up a step and I'm going to extrude this in just a little bit. And then I think we'll still be able to get a magnet in there. So let's step back 2 steps. What we're going to do is just create a new sketch off of this. Let's go out to the end and we'll make it, I don't know, 4. It's probably 4. And then we'll finish the sketch. And what we're going to do is extrude this by 2. And that should be plenty for that, I would think. So now let's step forward again. All right, so now we're good on that. And you'll see that when I do this, we're going to do a chamfer of 3. It'll actually kind of fill that in a little bit, see? So we're also going to we're going to chamfer that as well. and we're going to do a fillet on these. I just think it looks better. Let's do a fillet of 3. These actually do print pretty well when they're kind of at an angle. You wouldn't want to do it as a direct overhang though. Alright, so now on this, we're going to go ahead and take this thing. We're going to chamfer that, and let's see, let's say we're going to put it at 2, and actually let's go ahead and change that over to distance and angle, and I'll just angle it. Actually angle a little bit more. If we do 3.9, let's see what that gets us. I don't think we can do 4 exactly, but we're going to try it. Yeah, no. But if we do 3.9, we can put just a slight little fillet on each of those sides. So, right there. And right there. We should be able to just do like a 0.1 or a 0.2. Actually, let's just try 1. Alright, that seems to work. So, as you can see, we at least have kind of, it looks a little bit better that way. And I think we can still get our magnet in there. So we'll go with that. And I'll print that and test it and make sure it works. But yeah, this component's complete now. And let's go ahead and throw it on the printer. All right, so today we're going to work on the left side panels. So I've already generated the left 2U, the left 3U, and the left 5U panel. So today I'm going to walk you through how I derive the left 5U panel to become the left 4U panel. So the first thing we have to do is save the design. It's going to be left 4U panel. So once we've created that, let's go ahead and import the derive. You have to save before you can derive, so that's why. All right, so we're going to grab the entire component. Now, as you can see, we have some hinges here. This is where your back panels are going to meet into this. And then, as far as features, we don't need to remove anything like we did from the right side. There are no magnets that we have to work with. So this should be a really, really simple build. So the first thing we're going to do is we're going to go ahead and create a new sketch. So this new sketch is where we're going to create a couple of boxes that we're going to use as slicing tools. So the first thing we're going to do is take this up to about 120. And then, of course, we'll just latch onto the front there. All right. Now we're going to create another box, and this is going to be 40 tall. This is the U that we're going to cut out, if you will. So 40 and to the front. Cool. All right. So now that we have that, we can go ahead and use that as our slicing tool. So let's slice it up. All right, now we should have 3 bodies. We're going to go ahead and create a new component that we're going to move the top and the bottom to. We'll just name it the same thing. All right, so now that we have that, it already automatically switched us to that, which is good. So we'll go ahead and grab this. We'll grab the bodies. Should be that and that. Grab those, pull them in. Then we can just go ahead and turn this off. So now that we have this, we need to go ahead and drop that down onto it. So we're going to make it -40, and then we'll just combine the two. It's pretty much that simple. This component's done. So I've already got the back piece done, so it should work with this, and I'll throw it together as an assembly before I print it, but everything should be set now. If you wanted to make this like a 6U or something like that, you could just slice it up the same way that it was, and then add however many U's into that as you need. So you could stack up as much as you want, but 5 is about all that I need max in a particular set. I could see where you'd want more or less, but either way, I've given you 2, 3, 4, and 5, and you're welcome to modify as necessary. But this is pretty much done. At this point, I have a majority of the different U sizes rendered for the back panel. Today, I'm going to walk you through how to derive the 5U panel to be whatever size it is that you need. So in this case, I've got the 2, the 3, and the 5 generated, and we need a 4 to finish out the set. So let's go ahead and do that today. So we'll set this to be this. So rename and we'll name and save the design, and then I'm going to insert a derive from the 5U, which is what I initially designed and what I'll derive from that. So now that we have this, we're going to choose the full component and bring that in. Now that we have the full component here, what we're going to do is actually slice up this full component. So we're going to create a sketch. We'll do it on the root component of this. And we're going to sketch on this plane, not on the body. We want to do it on the plane because we're actually going to slice the body. So we'll take a new rectangle here. It's going to be 109 for my calculations, 109 and 130. And then in addition to that, we're going to create another rectangle, and that's going to be 40 and 130. Reason being, each one of these U's are 40 millimeters tall. And so since we're going to cut one 40 millimeter out of it, we'll just use this to slice it up. Now, the reason it's placed the way that it is because this is the top of the hinge mechanism here. So, like, this is where a hinge pin will slide in, and that slice right there will create essentially that same section there. We don't want to do it down here because if you'll see, we have a magnet section here. So let's go ahead and slice this up. You'll see what I mean in a minute. So we'll split this body right here, and you should see it'll break it up into 3 different bodies now. What we're going to do now is create a new component, and we'll actually just call this the same as the design. Now we're going to switch over to that. We're going to grab these bodies here. So this one and this one. We're going to move this to the new component. And then at this point, we can turn that off. So now that we have this new component, we have a couple of things we need to do. So first, we've got to move this down. So we'll take that down the minus 40. So that should put them together. And now what we're going to do is actually combine them into a single object. Now that we've got that combined into a single object, you'll see that it is essentially the design of the back panel. However, I'm a little extra, so what I'm going to do is I'm going to go ahead and make sure that I've got a section analysis for this. I'm just going to put it against this. We're going to take it back just a tiny little bit. And you'll see I have these sections right here that our magnets are going to fit into. Now what I'm going to do is insert some magnets. So I'm selected on that particular component, and I'm going to pull in my magnet real quick. So we'll insert that. So we're going to rotate it the way that we want it. So it's going to be 90. Oh, let's go back and try that again. So that's going to be 90, and then we're going to rotate it one more time, and that's going to be 90. We need to move it back just a little bit so we can see it when we do a joint. So we're going to grab this from here. All right, we'll put that right there. And then we got to do that one more time. All right. Now you should see that we have a completed component. From a section analysis, those are in the right spot. We have good spacing on either side. That is, this should be roughly 160. Not selected. All right, let's try that again. Yeah, so that should be 160. All right, so that's our 4U component. What we'll do is we'll go ahead and turn off the analysis, and we'll go ahead and save that. And this component is complete. So if you've been following along with where we're at currently in the build, you'll have a 2 and a 3U section. So let's go ahead and update the assembly with some 4U panels real quick. Alright, so rotate that 180. And what we're going to do is go ahead and we'll take this panel, turn it off, and we're going to create a new joint here. So this joint will be here to that, and it'll be, it's going to go back this way, 0.1, just like that. All right, and we can turn that one back on. Now we're going to add another one to the other side. So at the right 4U panel. All right, move that over and bring it up. Okay, that looks good to me. Let's go ahead and turn off this panel. Okay, that one right there, and we'll create a new joint here. That's gonna go to right there. That didn't actually work like it was supposed to. I guess I clicked the wrong thing. Okay, that to that. There we go, much better. All right, that's gonna go out 0.1. Okay, we'll turn this piece back on, and we're gonna go ahead and add a back panel now. Actually, let's add a mid rack too. I might as well. Okay, that's under derivable components. Take the mid rack, insert into the design. Okay, go up. Okay, let's go ahead and get a joint here. Joint from here to there. Okay, and I believe that one needs to go back that way, 0.1. Okay, now let's go ahead and add a back panel to this as well. Alright, 4U back panel, insert. We're going to take it back this way. I'm going to take it up. Let's go ahead and add, let's see, what were these joint limits? Those were, yeah, so 135. Okay. Let's go ahead and add a new revolve joint. Alright. We've got that. Let's make sure we've got it in the right spot. Alright, motion joint, revolute. Okay. We'll go ahead and edit the joint limit, and that's going to be minimum minus 135. Now let's make sure that it's actually in the right spot. If you look, we need to actually take it up just a touch. Alright, edit that joint. We can. Alright, edit joint, and we want to go up. Let's see, what was it? Alright, we'll do -1. I believe that's right. Okay, so now we have a completed 4U section. Anyway, thought you might want to see what the assembly looks like when it's essentially at the current state of released parts. So this is what you should have. So, all right, have a good weekend. This probably is going to be the last video I release until sometime next week, but I may surprise you. We'll see what happens. It all depends on what's going on this weekend. But yeah, so we're at a good point now. So one more set of panels to release, and then the top. Once the top is out, then I can start working on the trays. So making some good progress. The part that I made yesterday for the top didn't turn out exactly like I wanted it to, so I'm reprinting that, and once that's dialed in, we'll be able to move to the actual lid. But really good stuff. Anyway, later on.